Welcome to the Unit 4 Part 2 test review. Let's go ahead and get started. First two problems I have simplified completely. For number 1, I want you to recall that I squared is equal to -1, and anytime I see I squared, I should be replacing it with -1. So I have 12 times -1 minus 8 times -1, which is going to simplify to be -12 plus 8, which is -4. For number 2, this one's a little more complicated. I would say you should not expect something this difficult on the test. But remember, anytime I have a perfect square within the square root, I'm going to go ahead and simplify it. So I went ahead and rewrote everything first. I got -I square root of 4 times 2, because remember, I want to pull out any perfect squares. I have a 2I square root of 4 times 6 times 3, square root of -1 times 2. For the first one, I'm pulling out a 2. For the second one, I'm also pulling out a 2, and I get 2 times 2i is 4i. For my third one, I have an I coming out, so I have 3i square roots of 2. Now, one thing that we will cover again when we get back from winter break is how to simplify radicals. Notice that I have a square root of 2 and a square root of 2. What's really happening is if you have the same radical, what you can do is you can multiply the outside numbers and the inside numbers. So what I get is 3 times -2 is -6. I times I is I squared. Square root of 2 squared is square root of 4, which we can simplify. So this becomes 2. 2 times -6 is -12. I squared is -1, and then I have 4i square roots of 6. Now, this just requires a little bit of multiplication again. This is positive 12. 12 times 4 is 48. Can't do anything with the I, can't do anything with the square root of 6. Now, again, I would say you should not expect something this challenging, especially with radicals, on the test this Friday. So let's go ahead and look at our next couple of problems. 3 and 4, we again are simplifying. Remember, I have a square root of a value that I can actually take the square root of. So I just went ahead and rewrote this as -1 times 100. Square root of -1 is I. Square root of 100 is 10. I times I is I squared. And remember, anytime I see I squared, that should be simplifying to be -1. -1 times 10 is -10. For number 4, make sure you're distributing. The 3 is going to distribute to both numbers, and this negative is going to distribute to both numbers. Gives me -12 minus 15i minus 7 plus 12i. Combine like terms. -12 minus 7 is -19. -15i plus 12i is -3i. Looking at number 5, we are determining if x equals 1 minus 4i is a solution to x squared minus 2x plus 17. Well, in order to determine if it's a solution, we're going to have to plug in 1 minus 4i everywhere that you see an x. So I'm going to do 1 minus 4i squared minus 2 times 1 minus 4i plus 17 equals 0. Be careful here. This squared means I have to FOIL. So I have to do 1 minus 4i times 1 minus 4i. Once I FOIL that, I'm going to go ahead and distribute the -2 to both of these numbers in the parentheses. Gives me 1 minus 4i plus 16i squared minus 2 plus 8i plus 17 equals 0. I did a little bit of simplification. I combined this to be -8i. I simplified 16i squared to be -16. And here it's going to require us to start canceling some things out. -8i plus 8i cancel each other out. I get 1 plus 17 is 18. -16 minus 2 is -18. 18 minus 18 is 0. So therefore, x equals 1 minus 4i is a solution because this is a true statement. If it was false, we would say it's not a solution. Now, number 6 just happened to not appear on your version and mine, so we're just going to have a happy accident and a free question. For number 7, we are solving. Now, there are multiple ways you can kind of approach this. Anytime you just have a squared value and a number, I'm always going to suggest jump right into solving by square roots. So I have 5x squared equals negative 125. I divided both sides by 5 to give me x squared equals negative 25. And then I took the square root of both sides, making sure that I don't forget plus or minus. Anytime I have the square root of negative 25, I should be thinking of it as the square root of negative 1 times 25, which will happen to simplify as an I and as a 5. My answer should be x equals plus or minus 5i. Okay, for number 8, we are solving 3x squared plus 2x minus 1. Now, if the method is not indicated, which on your test it should be, you are free to try any of our 3 options. Remember, you can factor, you can complete the square, you can use the quadratic formula. For this one, it is factorable, so that's the route I took. It multiplies to be negative 3, adds to be 2, split the middle term with negative 1 and positive 3. Group the first 2, the GCF is x. Group the second 2, the GCF is positive 1. That leaves me with 3x minus 1, x plus 1. X should be equal to 1/3, and x should be equal to negative 1. Now, you should get the same answer no matter what method you use. It's just some tend to be easier than others. For solving number 9, I went ahead and approached this as a complete the square problem, just because I know there's no way to multiply to get 15 and add to get negative 10. And I just kind of wanted to show you another example and didn't jump straight into quadratic formula. So I subtracted 15 from both sides, and I identified my b to be negative 10. b over 2 is negative 5. b over 2 squared is 25. With that, I get my factored form is x minus 5 squared is equal to negative 15 plus 25, which is 10. Took the square roots of both sides. Don't forget your plus or minus. I get x minus 5 is equal to plus or minus square roots of 10. Square root of 10 is not going to do any simplification, so our final step is to add 5 to both sides. So x should be equal to 5 plus or minus square roots of 10. Now for number 10, I believe I approached this problem again with factoring. I noticed that I have 2 things in common, which is a GCF. So I pulled out an x in front, and that left me with x plus 18. This tends to be one of the trickier ones for you guys. Remember, x is a factor as well. So I'm going to set x equal to 0, and then I set x plus 18 equal to 0, which gives me x equals negative 18. For number 11, I went ahead and moved everything to one side. Now, this is something you could easily factor, but I did want to show you how to use the quadratic formula as well. I identified A, B, and C, and I plugged it into the quadratic formula. Remember, you are able to use your notes, so please have that handy just in case you do decide to go this route. I end up with square root of 49, which simplifies to 7. I do have 2 solutions. One is going to be the plus, one is going to be the minus. So negative 1 plus 7 is 6 all over 8. If you can simplify your fraction, you should. This simplifies to 3 over 4. Negative 1 minus 7 is negative 8 over 8, which is negative 1. Now, looking at number 12, we've done a problem like this as a warm-up. I have create an equation with the roots x equals 8 plus or minus I square root of 68 all over 6. Now, the only thing different and tricky about this problem is they have I square root of 68. My discriminant for this problem is not 68. Remember, I is when we take out a negative 1 from the square root. So really, my discriminant is negative 68. So what I did, again, referencing the quadratic formula, 8 should be equal to negative b because it's negative b plus or minus. So negative b is equal to 8, meaning b is negative 8. 6 should be equivalent to 2a because it's all over 2a. So 2a equals 6, therefore a should equal 3. Now, the discriminant of the quadratic formula is b squared minus 4ac. Well, we know most of these values. We know b is negative 8 squared minus 4. We know a is 3. We need to figure out what c is, but we know that the discriminant is equal to negative 68. So what I'm going to do is some simplification. I get 64 minus 12c equals negative 68. Negative 12c is equal to negative 132. If I divide both sides by negative 12, I get c is equal to 11. One thing you do not want to forget for a problem like this is to actually answer the question. Write the equation. Y equals 3x squared minus 8x plus 11. Now for number 13, we are going to find a possible pair of integer values for a and c so that the quadratic equation ax squared plus 4x plus c equals 0 has two imaginary solutions, and then write the equation. Now, first thing, remember that two imaginary solutions are indicated by a negative discriminant. So b squared minus 4ac should be a negative number. Now, this is a problem where there's more than one correct answer. It depends on what negative number you picked. This number here could be anything. It could be any negative number that you decide to use. For me, I just picked negative 8. You could have picked negative 4, could have picked negative 2, could have picked negative 1. As long as this number is negative, you should get correct answers. So I went ahead and plugged in my b value of 4. 4 squared minus 4ac gave me 16. I went ahead and subtracted 16 from both sides, which gave me negative 4ac is equal to negative 24. And then I get ac is equal to 6. And then I just have to think of two numbers that multiply to be 6. You could have picked 6 and 1. I just went with 2 and 3. One thing I just talked about is do not forget to answer the question. So we should have y is equal to 2x squared plus 4x plus 3. This should be our answer along with our a and c value. Okay, let's go ahead and look at number 14. We're going to find a number such that the square, and remember a square is if I have anything squared, of 1 more than the number is 4 more than 4 times the number. Well, if I have a number x, 1 more than that number is x plus 1, and the square of that is that parentheses squared. 4 times the number is 4x. 4 more than that is plus 4. So this is how your setup of equations should be. Once I have my left side foiled, I'm going to go ahead and move everything to one side. Gives me x squared minus 2x minus 3 is equal to 0. And this is something we can factor. It factors into x plus 1, x minus 3. Therefore, x is equal to negative 1 and x is equal to 3. Be careful with these types of problems. This just says to find a number, so both of these answers are okay. Sometimes it asks for a positive number. Sometimes it asks for a negative number. So make sure you're picking the right choice based on a question. For number 15, let the product of two consecutive odd integers. The product of two consecutive odd integers is 1 less than 4 times their sum. Find the two integers. So I said let x be odd. So the product of two consecutive odd integers would be x times x plus 2, because I have to move 2 numbers to get to the next odd one. 1 less, here's my 1 less, 4 times their sum. So when I add x and x plus 2, I'm going to get 2x plus 2, 4 times their sum. Again, a little bit of simplification, did some multiplication, did some distributing and combining, moved everything to one side, factored, and I set each factor equal to 0 to give me x equals negative 1 and x equals 7. Well, the next consecutive odd for these two would be 1 and 9. So my final answer would be -1 and 1 and 7 and 9. Again, please pay attention to whether it's asking you for positive or negatives, because that will be important for your test. Okay, I'm going to spend some time walking you through the calculator steps for 16 and 17. I already have my equation for 16 in my calculator. I'm going to go ahead and work through setting up my window. I always look at the table, so second graph, and I try to find what is the highest y value that I can see. And in this case, it looks like it's going up to 896 and then coming back down. So I'm going to have to set my y max higher than that. And then I like to see also, when do my y values turn negative? They turn negative at x equals 16. So my x max needs to be at least 16. Let's go ahead and look at our window. I'm going to go ahead and leave my x-min. You know what? I'm going to change it to be -1. I'd like to see a little bit of cushion. I might come back and adjust that in a second. My x max, remember we said it has to be 16. I usually round it up to the next 10th. So I'm going to go to 20. My y min, I like to leave it below the x-axis just so that I can see where it crosses. I'm going to leave it at -10 for now. I might have to change it because I know my y max is going to be pretty big. The highest number that we saw was 896, but I'm going to go all the way up to 1,000 just to be safe. Matter of fact, I'm going to change this to negative. Let's go -50 just so I can make sure that I clearly see the place where it crosses. So I'm going to graph. And again, remember, you want to see where your graph starts, where its maximum is, where it crosses the x-axis again. So we are in a good place. When will the ball reach a height of 800 feet? I'm going to go to y equals, I'm going to press enter, I'm going to go to 800, and back to my graph, and I should see 2 intersection points. To find those values, I'm going to go second, trace, intersect, move my cursor all the way to the left, enter, enter, enter. First time is 5 seconds. Do the same thing again, second trace, intersect. This time I'll have to move my cursor over to the right intersection, enter, enter, enter. And the second time is 10 seconds. Don't forget to include your units. Now back to my calculator. I'm going to see, when will the ball reach the ground? That is this point here where we cross the x-axis. This is a height of 0. So I'm going to go to second, trace, number 2, 0. It's going to ask me for a left bound. So I'm going to move my cursor a little bit closer. And as long as it's above the x-axis, we're good. And then I'm going to move it to be below the x-axis. And I can't see it, but I know it's down here because it says y is -55. So I'm going to hit enter. And you should see some bounds around where your graph crosses the x-axis. If you cannot see the x-intercept in your window, your graph will say there is none. So you have to make sure your window is set correctly. So I'm going to press enter, and it's going to tell me it hits the ground at 15 seconds. When will the ball reach its maximum height? I'm going to go second, trace, maximum. And it's going to ask me again for a left bound. So I'm going to move to the left of my maximum point, move to the right of my maximum point, hit enter one more time. It reaches its maximum height at 7.49999. We round it to 2 decimal places, so 7.50 seconds. And its maximum height is 900 feet. So there is number 16. Okay, looking at number 17, I already have my equation in my calculator. The next thing I have to do is adjust my window. So I'm going to go second, graph, and I'm going to see that if I scroll through my values, they keep increasing, 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 and then they start decreasing. That means my maximum is somewhere in here, and the highest value I see is 511. So I'm probably going to set my Y max to be about 600 just to be safe. And then the next thing I like to notice is when do my y values become negative? They become negative at x equals 21. I'm going to go ahead and make my x max 25. So I have -1 to 25, and then I have -50 to 600. Just to give myself a little bit of cushion to make sure that I see all of those key points when I hit graph. And look, I see my starting point, my maximum, and my ending point. So we're going to calculate the height after 3 seconds. So I'm going to do second trace. I'm going to go to value because I want to know when x equals 3, what does y equal? In this case, it's 256.9 meters. And then at what time will it be 480 meters high? I'm going to go to y equals y2. I'm going to put 480, and you should see 2 intersection points. Second trace, intersect. Going to move it to my left intersection. 1, 2, 3. It happens at 7.68 seconds. Going to repeat the process. Second trace, number 5. Going to move my cursor closer to the right intersection. 1, 2, 3. 12.73 seconds is the other time. When will the cannonball reach its max height? Second trace, number 4. Going to move my cursor to be to the left of the maximum. Move my cursor to be to the right of the maximum. One more enter, and it reaches its maximum height at 10.20 seconds, with its max height being 511.20 meters. For number 18, I have identify the features of the parabola and graph it. Well, first thing you should always do is try to see what equation matches what you are given. So I can see that the y value is squared. So that means my graph is either opening to the right or to the left. The next thing you want to look at is the value in front of the other side, positive or negative. In this case, it's positive. So I should be using the formula y minus k squared is equal to 4p x minus h, which means my parabola is going to be opening to the right. Now I'm just going to start identifying different features. First thing I always do is look for my vertex. My vertex is hk, so in our case, h is -3, k is +1, so my vertex should be at -3, 1. And my value of p, if I take 4p and I set it equal to 4, I'm going to get p equals 1. Now, from here, I graph. I start to try to visualize what this looks like. If my vertex is at -3, 1, remember, p is the distance from the vertex to the focus and from the vertex to the directrix. So I should be only going to the right 1 unit to get the focus, and to the left 1 unit to get to the directrix. So my focus should be -2, 1. My directrix should be x equals -4. The axis of symmetry is, if it's a left-right parabola, it's the horizontal line splitting your parabola in half. So it has mirror reflection. So the formula for the axis of symmetry for this problem is y equals 1. Domain starts at -3, goes all the way out to infinity. Range could be any possible y value that you have. So 19 and 20, create a parabola. Let's get 19 first. Create a parabola with a vertex as 4, 2 and a focus at 7, 2. I am always going to suggest sketching a picture. My vertex is at 4, 2. My focus is at 7, 2. Now, the focus is always inside the parabola. So if the focus has to be inside the parabola, that means I have no other choice but for my graph to open to the right. Now, the next thing that's important, because now that I know it's opening to the right, I know that this is the formula I should be plugging in. I know h and I know k from the vertex, but I need to figure out what is p so that I can finish out my equation. Well, p is the distance from the vertex to the focus. So if I count, it's 1, 2, 3. So my p should be equal to 3. So all I did was plug in p is equal to 3 into this formula. I get y minus 2 squared is equal to 12 times x minus 4. Same thing almost for the last problem. Create a parabola with a focus at -4, 5 and a directrix at x equals -2. Again, I always suggest sketching what you have. For us, a focus at -4, 5 is here. My directrix is at x equals -2. Now, the vertex is going to be the point in between your focus and your directrix. So I don't have very much space to work with, but I know that if there's 2 units, the midpoint is 1 unit away. So my vertex is sitting here at -3, +5. So I plug that in for hk. So h is -3, k is +5. The next thing I need is my p-value, which is the distance from either the vertex to the focus or the vertex to the directrix. Pretty easy in this case. All it is p is equal to 1. So p is equal to 1. Do a little bit of simplification. Y minus 5 squared is equal to -4 because, again, remember, directrix is outside, focus is inside. So the only option I have is for my parabola to be to the left-facing direction. X plus 3 should be your final answer.